This is the Advanced Unit 3 Equations review. I'm just going to run through all the questions on the review with you. So in the first couple, we're going to go ahead and simplify the expression. So we're using distributive property, and we're also combining like terms here. So in the first example, I'm just combining like terms. They're both x's. I get 17x. In the second example, I have different variables here, so I'm going to actually combine them separately. So first would be alphabetical order, so we're going to go y first. Positive 8y and negative 2y is positive 6y. 5 and a negative 8 is a negative 3z. The next one I have k's and q's, so alphabetical order would come first k. Negative 7 and a negative 1 is negative 8k. I have 3q and 2q, so that's going to be a positive 5q. In question number 4, I'm first going to go ahead and distribute the 3. That'll give me a 6x plus 12 plus the 6x that was already there. 6x plus 6x is 12x plus 12. In question number 5, we're going to distribute the positive 3 here, and we're going to bring down the negative 8x out front, plus 21x minus 6. Combining the like terms with the x's here, we have negative 8 plus 21 is going to give us 13x minus 6. In the last example, we're going to distribute the negative 6 first, which will give us negative 24r minus 12. Then we'll distribute the positive 8, which will give us plus 24r minus 16. So we're going to combine the r's together, which will give us 0r. We have a negative 12 and a negative 16, which will give us negative 28. Best answer here would just be a negative 28 because we would not include 0r. Starting at question number 7, we're talking about equations here. Mrs. Ferguson set up a balance scale using squirrels and crates with squirrels inside of them. How many squirrels are inside each crate? So the crates are going to cancel, one crate will cancel off with another, and the one squirrel over here will cancel off with the other squirrel. So here we have 2 squirrels and we have 1 crate, so we would have 2 squirrels is equal to 1 crate then. Taking a look at question 8, starting here, we're solving equations. Write no solution or infinitely many solutions if it's necessary. Remember, those are only special cases, so we're not going to see them that often. We're going to go ahead and subtract the 15 on both sides here, which will leave me with negative 6x equals negative 18. Divide through by negative 6, and I'm going to get x equals positive 3. In this next one, I'm going to add 9 to both sides. That'll give me z over negative 6, which will be equal to a negative 3. Multiplying by negative 6, z is going to be equal to a positive 18 then. Number 10, this is that junk in the trunk birthday present. We're going to multiply by 6 on both sides. That leaves us with y minus 4 is equal to 6. Adding 4 to both sides, we get y equals 10. Question number 11 here. We're going to combine our like terms first, giving us negative 9h minus 6 is equal to a negative 78. Adding 6 to both sides, we're going to get negative 9h is equal to a negative 72. Dividing through by negative 9, we're going to find out h is equal to 8. Question 12, we have variables on both sides, so we're going to move the smaller one, which is the 2j. This will cancel out. Negative 1 is equal to negative 13, and positive 8 minus 2j is going to be a positive 6j. We're going to go ahead and add 13 to both sides. Negative 1 plus a 13 is a 12 equals 6j. Dividing through by 6, we get 2 is equal to j. In number 13, we're going to distribute the 6. We get 6m plus 18 minus 2m equals 2. 6m minus 2m combined together to give us 4m plus 18 equals 2. Subtract away the 18 on both sides. We're left with 4m equals negative 16. Dividing through by 4, we get m is equal to negative 4. That's a terrible looking 4 there. Question number 14, drop a line down our equal sign. Distribute your 10 first. So we get 10x plus 20 minus 5x minus 8 equals, over here we just have 5x plus 24. Remember, we're using don't call me after midnight here, so combining my like terms, 10x minus 5x will give me 5x. A positive 20 and a negative 8 will give me a plus 12 is equal to a 5x plus a 24. So 5x, I'm going to subtract 5x here. And you probably noticed that we're going to end up with 12 equals 24, and that is not true. So this is what we would call a no solution situation. Taking a look at question 15, we're going to distribute the negative 3. So we get negative 3k plus that's 42 is equal to a negative 10k. We're going to move the negative 3k since the negative 10k is all the way over here by itself already. So we'll have 42 equals negative 7k. Dividing through by negative 7, we get negative 6 equals k for our answer. Question number 16, distribute first. So we have this positive 3 to distribute. Bring down my 6r plus 12r minus 24 equals. I can also combine my like terms here. So I see a negative r and a 19r. That'll give me 18r, and I have a minus 24. Combine my like terms over here. This is going to give me 18r minus 24 equals 18r minus 24. And this is a special situation because the sides are equal. And when that happens, this is called infinite solutions. Question 17, this one looks disastrous. So we're going to go ahead and distribute first. I'm going to distribute my positive 2, bringing down this 2 that's out front. Positive 2 times 20 is positive 40v. 2 times negative 8 is negative 16 minus 8v. Distributing my 3v plus 27. Distributing my negative 4 minus 4v minus 8. Okay, combining like terms, positive 40, negative 8, that's going to give me 32v. 2 and a negative 16 will give me negative 14. Over here, 3v minus 4v will give me negative v. Positive 27 minus 8 is going to give me positive 19. I'm going to go ahead and move this minus v, so add v to both sides. 33v minus 14 equals 19. Adding 14 on both sides, I'm going to get 33v equals 33. So divide by 33, and we just get v equals 1. Answer the questions that follow. So a circus costs $7 to enter, plus an additional $10 per ticket to ride the elephant. Ooh. Write an algebraic expression, that means no equal sign, to represent the total cost for a visit to the fair. Let T represent the number of ride tickets purchased. So $7 to enter plus $10 per ticket. So this is going to be T, so 10 times T. We're going to make that a little bit curly so it doesn't look like our plus sign. Part B, what is the total cost of your visit to the fair if you bought 15 tickets? So we're going to have 7 plus 10 times 15. I'm going to go ahead and do these first. So that's 150 plus 7. So it's $157 if you bought 15 tickets to ride the elephant. For the next couple, we're going to write and solve equations. So Jake works at Wawa, and he earns $9 for each hour. So I'm thinking 9 times X here. This week, he needs to buy new clothes that cost him $80. So costing him would take away from what he earns, and he still wants to earn $55 for the week after paying for his clothes. How many hours will Jake need to work this week? So he has $9 per hour, and he's going to subtract the $80 that his clothes cost him. And after he's done with that, he's still looking to make $55. So we're going to go ahead and add 80 to both sides. And that'll give us 9x is equal to 55 plus 80 will be 135. Divide through by 9. And that's going to give us x equals 15. So we would say 15 hours Jake would need to work. Question 20, the sum of 3 consecutive integers. These are that number 1 is x, number 2, and number 3. So x, they're consecutive integers. X would just mean the next one would be x plus 1, and the one after that would be x plus 2, because we're just counting here. So the sum is 156. We have x plus 1 plus x plus 2 is going to be 156. Combining your like terms, you get 3x plus 3 equals 156. And we're going to go ahead and subtract the 3. So we get 3x equals 153. We're going to divide through by 3, so we get x equals 51. So if x is 51, x plus 1 is 52, and x plus 3 would be 53. Last one, number 21. Jessica and Monique are saving money to go shopping. Jessica starts with $14 and she saves $3 each week. So this one's going to get my X. Monique starts with $2 and saves $6 each week. At what week will they have the same amount of money? Saw that one coming. So we have 14 plus the 3X for Jessica. Monique is 2 plus 6X. And if we subtract the smaller variable, which is our 3x, we have 14 equals 2 plus 3x. Subtracting away the 2, 14 minus 2 is 2 equal, oh my gosh, 12, hello, equals 3x. Divide through by 3. We get 4 equals x. So at week 4, they are the same. And that wraps it up then for our review for Unit 3, Equations Unit.